Okay, so we're going to take a look at what it means for a sequence to be bounded. A bound on a sequence is a y value, or more accurately, it's a horizontal line that has the equation y equals some sort of number. Okay, so if our sequence is bounded from above, there is a number capital M, so it would be like y equals capital M, such that all the terms of our sequence are below that line. Okay, for all n. So we would write that as a sub n is less than or equal to capital M, and we would call that our upper bound. Okay, similarly, if our sequence is bounded from below, there is a number lowercase m, so that would be y equals lowercase m, such that all the terms of the sequence are going to be bigger than or equal to little m. So we would write that as a sub n is greater than or equal to lowercase m. We would call that a lower bound. Okay, so one thing to note about this is that bounds are not unique. So I can have many upper bounds. So here's my y equals m as an upper bound. Here's another line that's an upper bound. And I could draw another line up here. It would also be an upper bound since all the terms of the sequence stay below that line. Okay, so our bounds are not unique, but they do give us some important properties. So one note about how a sequence can fit in with bounds. So our sequence can be bounded below. Okay, it could be bounded above. It could be bounded both above and below. Or it can be not bounded at all. Okay, so those would be kind of our 4 possibilities. So either below, above, both above and below, or not bounded at all. Okay, so how does this relate to convergence of sequences? So it turns out that if we know our sequence converges, then we also know that it is bounded. So if a sub n converges, then it is bounded, which is kind of a nice property to have. Okay, one thing to note is that the reverse is not true. So that means that just because a sequence is bounded does not mean that it is guaranteed to converge. Okay, so let's look at an example of that. So suppose I was interested in the sequence a sub n is equal to sine of n. Okay. So I know that sine is bounded above and below by -1 and +1. Let's put some bounds in here. So here's my +1 and here's my -1. And if I look at sine, right, I can start putting these dots in for the sequence. Okay, and so it definitely is bounded both by -1 and +1, but this is never going to converge. This limit sign is does not exist. So just because it's bounded doesn't mean it will converge. However, the reverse is true. If it converges, we're guaranteed that it's bounded.